Welcome to This Explainer. I want you to close your eyes for just a second and really try to imagine the absolute edge of everything you know. Today, we're embarking on a mind-bending journey of escalating cosmic scale. We're going from the impending fate of our local neighborhood to invisible predators drifting through the void, all the way to structures so impossibly massive they're literally rewriting the laws of physics as we know them.
Okay, let's dive into this. The universe is too big, too wild, and too creative to fit into our narrow molds. I absolutely love this quote because it perfectly captures what we're going to uncover today. You see, the universe isn't just a static, perfectly predictable painting. It's an active, chaotic, and unimaginably grand machine that is constantly shattering our perception of physics, time, and scale. Basically, we're going to rip up the old textbooks today.
Act 1. The Fate of Our Home.
Now, what's really interesting about this slide is the sheer difference in mass and scale between our home and our closest large neighbor. Andromeda contains roughly 1 trillion stars and spans 200,000 light-years across. It is more than twice the size of the Milky Way. And right now, as we speak, it is bearing down on us at a staggering speed of 110 kilometers per second. It's out there in our night sky right now, and it's slowly growing.
So, this isn't going to be some quick, explosive crash. It's more like a patient, inevitable gravitational dance. Over the next billion years, Andromeda will get noticeably larger. By 2 billion years, it completely dominates the night sky. 3 billion years, it fills half the sky. And then around 4 to 5 billion years from now, we get contact and merger. Gravity is going to warp the heavens, completely ripping spiral arms apart and triggering these massive bursts of new star formation. Over 2 billion years of swinging through each other, the Milky Way and Andromeda will merge into a massive new elliptical galaxy that a lot of people call Milkomeda. Our sun will probably survive the whole shebang, but our night sky and our home as we currently know it will cease to exist.
Act 2. A universe of 2 trillion.
If a galactic collision sounds unimaginably huge, you might want to brace yourself, because we are about to shatter your sense of scale entirely. And we have the James Webb Space Telescope to thank for this. For nearly 30 years, textbooks taught us that the observable universe contained roughly 200 billion galaxies. But when James Webb opened its shutters and looked at the exact same patches of sky as Hubble, it proved that old number was wrong by an exact factor of 10. There are 2 trillion galaxies out there. 2 trillion.
So the crucial point is understanding exactly why we missed 90% of the universe for an entire generation. It comes down to cosmological redshift. Since the universe is expanding, as ancient light travels across billions of light years, that expansion actually stretches its wavelength. So energetic, visible ultraviolet light gets stretched right out into invisible infrared light. Now, Hubble was an absolutely magnificent visible light telescope, but it was completely blind to this reddened ancient light. James Webb, on the other hand, was purpose-built to see an infrared, which completely revealed an entire hidden reality that was just hiding in the dark.
But honestly, what Webb found in that infrared light completely broke our models. According to our standard, slow-bake model of astrophysics, early galaxies were supposed to be chaotic, clumpy, and really small. But Webb found absolute monsters. Take Maisie's galaxy, which was impossibly bright just 390 million years after the Big Bang. Or Sears-Ash 2112, which was this mature, stable, barred spiral galaxy billions of years before it had any right to exist. And then there's GLAS Z13, packing a billion solar masses of stars at a time when there simply shouldn't have been enough time to assemble them. The universe didn't slowly bake these galaxies, it blasted them into existence at hyperspeed.
Facing 2 trillion galaxies and these impossible cosmic dawn anomalies can honestly make humanity feel incredibly small. The silence of all those galaxies is deafening, right? But think about this. We are the witnesses of the universe. We are its memory. A 13.5 billion-year-old photon was just a packet of energy traveling through a void until it hit our telescope. It's our present consciousness that transforms that light into a discovery. Our brief, fragile moment in time is exactly what gives these ancient photons their meaning.
Act 3. Ghosts between the stars.
Let's shift our gaze back to our own galaxy for a second, because beyond those bright, beautiful spirals, the void is harboring a completely invisible, terrifying predator. Right now, there are an estimated 100 million rogue black holes drifting through the Milky Way. When massive stars die, they sometimes collapse with just a tiny fraction of a percent of asymmetry. But that uneven explosion acts like a massive cosmic shotgun, violently kicking the newly formed black hole right out of its solar system. So now, they just wander the void at 100,000 miles per hour, completely detached, silent, and starving.
Now, because these city-sized ghosts have no accretion disk to feed on, they emit absolutely zero light. So how do you spot a 30-meter-wide sphere of perfect darkness? Well, you have to look for its footprints using gravitational microlensing. As a rogue black hole drifts in front of a distant background star, its intense gravity literally bends the fabric of space, acting just like a cosmic magnifying glass. It violently distorts and brightens the star's light into a blazing optical illusion. By measuring that microscopic wobble of light, we can actually detect the unseen predator passing by.
Which naturally brings us to a terrifying question. With 100 million invisible black holes wandering the galaxy, could a ghost hit Earth? Well, you can breathe a sigh of relief because the short answer is that the odds of a direct hit are practically zero. Space is just way too vast. But here's the kicker. A rogue black hole doesn't actually need to hit Earth to destroy it. It just needs to brush past the absolute outer edges of our solar system.
And this brilliantly illustrates the horrifying silent reality of deep space physics. Surrounding our solar system is the Oort cloud, which is this fragile shell of trillions of icy comets. If a ghost drifted silently through that deep freeze, its immense gravity would gently warp space, shifting the momentum of those comets by just millimeters per second. We wouldn't even see it happen. But millennia later, long after the ghost is gone, millions of dislodged comets would fall inward, creating an inescapable comet bombardment on the inner planets. It's essentially a trigger pulled in the dark.
Act 4. The Physics-Breaking Abyss. We've talked about our local galaxy, the distant dawn of time, and wandering ghosts. Now, let's travel to the center of the Phoenix cluster to see a monster that fundamentally shouldn't exist. You see, physics enforces a ceiling on how large a black hole can grow by feeding, known as the Eddington limit. As gas spirals into an accretion disk, it superheats and blasts radiation outward. At a certain point, the outward pressure of the light perfectly matches the inward pull of gravity, effectively blowing its own food supply away. This limit is supposed to act as the universe's built-in braking system, capping black hole growth at around 50 billion suns.
But the shadow at the center of the Phoenix cluster clearly didn't get the memo. Phoenix A star is estimated to be 100 billion solar masses. Let that sink in. It is double the theoretical Eddington ceiling. It's so impossibly massive that astronomers literally had to invent an entirely new category just to describe it, the SLAB, or stupendously large black hole.
Let's move on and see how this builds into true cosmic dread. The event horizon of Phoenix A star is roughly 590 billion kilometers across. If you plopped it right into our solar system, it wouldn't just swallow Earth, it would swallow the entire Oort cloud. Light itself would take weeks just to cross the diameter of this shadow. And honestly, the most terrifying part? All of that mass is entirely concentrated at the tiny singularity in the center. That means the interior is essentially a hollow, pitch-black cathedral of mostly empty space. If you crossed the horizon, you'd fall for weeks in perfect silence before finally reaching the end.
Typically, supermassive black holes act as these cosmic executioners, blasting out jets that superheat gas and stop new stars from forming. But Phoenix A star is so massive and its environment is so chaotic that its braking system has completely failed. Instead of sterilizing its galaxy, its jets are carving out massive cavities that actually allow gas to cool rapidly. This runaway cooling flow has triggered a massive stellar forge, igniting 700 solar masses of new stars every single year. It's a failed executioner, blindly flooding the dark with life because it just can't shut the forge down.
So, how did a black hole bypass the Eddington limit to reach 100 billion solar masses? Well, astrophysicists theorize that monsters like Phoenix A star didn't actually start from dead stars. Instead, we're talking about the direct collapse of pristine clouds. Back in the early universe, massive clouds of pure hydrogen and helium, without any heavy metals to cool and fragment them, might have just grown too heavy and collapsed all at once. Tens of thousands of solar masses caving straight into the dark instantly, giving these super predators a terrifying head start from the very dawn of time.
Which leaves us with one final awe-inspiring question to ponder. If our physics are struggling to explain these impossibly mature galaxies and stupendously large black holes at the dawn of time, what if they aren't from the dawn of time at all? What if the Big Bang wasn't a beginning, but merely the echo of a previous universe's violent death? A cyclical universe of eternal rebirths, holding secrets far older than our fragile 13.8 billion years. It's a breathtakingly beautiful, yet terrifying reminder of our cosmic fragility. Thank you so much for joining me on this explainer. Until next time, keep looking up.